Hello, everyone. Welcome to the part 2 of lecture week 12. So in this portion, we are going to talk about the fundamental theorem of calculus, so which is a very important theorem in calculus. And let's dive in. So if f is a continuous function on this interval, right? So I have this function here, and then we have this interval. And we also assume that we express the antiderivative of f, basically integration of f as uppercase f, right? Then this is what we can use. So the definite interval, right, starting from a and ending at b, then this can be just the difference, right, between these 2 points. So these are 2 points. So the evaluation of the uppercase f, the raw function, right, the uppercase f at these 2 points. So that's simply the how we can calculate, right? Okay, so now what does this mean, right? So for example, in the past, we have the integral of f of x dx. This is what we call an indefinite integral, right? And then we can express this f of x plus a constant c, right? So plus a constant c. So that's what we use the uppercase f to express the antiderivative of the lowercase f, right? And then you can just have this function and then evaluate at these 2 points to the start point and end point, and then take a difference. So we can just calculate. And sometimes it's also expressed as f, right, of x. And then we just use this vertical bar to express that. So we're going to take the difference between b and a, these 2 points, right? So this is simply. Okay, so let's get some practice. Before we practice, let's talk about some properties. So first one is that the if is from itself, right? So we still have the same interpretation, which is area under the curve. Now, what is the area? So the area is actually 0, right? Because it's just from this point to this point. Okay, so and if we plug in the theorem, it's gonna give us fa minus fa, which is again equal to 0, right? So we can just verify it like this. Now, the second point is that if we start from A to B, then if we start from B to A, the relationship is just minus of what the other, right? So take the negative sign. Why is that case? Because we just plug in the theorem, then we have FB minus FA, which will be exactly equal to minus FA minus FB, right? Remember that's the sign here on each term because of torsionality of the area. Okay, so now, so this is what it's about. Okay, so third is that if we have this and then have constant multiplier, we can just move this multiplier outside, right? Move it outside. So to see this, for example, you have KFB, right? So minus KFA. If we just do the evaluation, we can just have K multiply and then move K out as a factor, right? And then this is what we have. Okay, so we just can move K out. So this one similarly, if it's a plus minus, then we can just distribute the integral operation to each term, right? So I have the first term and the second term, and then again plus minus. Okay, so the last point is that if we start from A and end from C, then we can just find adding the points B, and we have this kind of expressive. So break it down into 2 terms, right? So first term, second term. So for example, if this is my area, right? So this is A, this is C, then this is C. Then just find any middle point B, and then this can be the first area, is going to be the second area, and just add them together, right? So now plug in the theorem, we have FC minus f of A will be equal to 2 parts, right? So first it's going to be B minus A, and then plus C minus B. So f of C minus f of B. And naturally, this B will cancel out each other. So it's going to be the origin expression. Okay, so all right, so exercise. Now for this one, so first, so there are a few steps. First, we need to get to know what is f of x, right? And then we evaluate at 2 points, which is 2 and 1. So these are 2 steps. So first, let's calculate the what is f of x. So f of x is going to be equal to, again, without the starting and end points. So 2x, let me just write it down. And this is what we have. And then, of course, the integral itself, based on the properties we introduced, we can just separate into 3 different terms, right? So 3 different terms. I'm just moving this minus sign outside. And also, I can just again move it, the constants. So constants come outside. And this is what we have. So again, this is 4, right? So 4 is a constant, 1 over x dx. Okay, so now where are we? So here we have simple terms. One take out antiderivative. So again, use a bit of rules we covered earlier that we know this is going to be 2 multiply x squared over 2, right? And then this is a power function. And then 3 multiply e to the power of x, because ex, the derivative is going to be itself, also the antiderivative as well. And just minus so which function gives us so 1 over x is going to be ln x derivative, right? So if you take the integral, then it's going to be ln x itself, right? So assuming now x above 0, okay? So why you can assume that? Because otherwise it's going to be absolute value. So because now it's going to be from 1 to 2, right? So we can just remove the modulus. So it's going to be 4 times ln x, right? So this is 4 times ln x. And that should actually be a constant c, yeah, just to represent the general constant. But in this case, we set c equal to 0, right? It just makes things simpler because at the end of the day, when these 2 starting point and endpoints cancel each other out, c does not matter, right? C will cancel out. Okay, so this is what I have. Now, what's left is just to plug in the value, right? So plug in the value. We just have f2 minus f1, and we just plug in the definition of f and then do the calculation, which will give us results, right? Okay, so last point is area under the curve. So when we have 2 curves, right? So how to calculate 2 curves, which you can just use this expression to calculate the area, which is, for example, this one and this one. Just take the difference of this function and then do the integration from the starting points and end points. Right? So this is exactly how we can calculate the area on the 2 curves or between 2 curves. Okay, so let's look at one example here. So in this example, we're looking at 2 functions. The first function is f, the second function is y. Y is actually the x-axis, right? So it's actually easy to compute because you can also draw the graph out, right? So f of x is going to be something like this. So now between 1 and 4, so this is 1, and this is, for example, 4. So let me just draw 2 lines, and this is the area we want to calculate, right? So this area we want to calculate. Now, so in order to calculate the area, we can just take the difference between these 2 functions. So this is the difference between these 2 functions, right? And then integrate it between the starting points and end points. And then we have the dx here because we are doing the integration, right? So now the result of the integration will be something like this. So we have 3x squared minus x cubed over 3, right? So I leave it up to you to verify the calculations. So this is the integrand, integral. And then we can just evaluate this integral at 2 points. One is 4, one is 1, right? So in this case, we can just plug in 4 and then plug in 1. So let me just plug in for you. So it's going to be 3 times 4 square minus 4 cube over 3, right? So this is the first part, and we have the second part, which is just this, right? So then we can just plug in and then do the calculation to get the area on the between these two curves. All right, so that's it for this review, and thanks for watching.